Okay, in this question, we are given that x is a random variable that is normally distributed with mean 17.4. So this means immediately that the mean mu is 17.4 and variance 7.84. So you know that when you have the variance, you need the standard deviation. So what you do is you take the square root of the variance to get the standard deviation. So this square root will be exactly 2.8. So this would be our standard deviation. Remember, when you're given the variance, you need to take its square root to get the standard deviation. So now the question is find the probabilities. The first one in A is the probability that x is bigger than 14.6. Notice that, so let's first put this here between them, and the probability that x is bigger than 14.6, we will change this to the z-score so that we can use the z-table to solve it. So this in A, this is the same as the probability. Instead of x, you put x minus mu over sigma. This is the z-score. Remember, I will write it here. The z-score of an x of a data value is x minus the mean over the standard deviation. So now this will be bigger than, you want it bigger than 14.6 minus the mean, which is, we found it here, 17.4, it's given, divided by the standard deviation, we found it 2.8. And so this will be the probability that z is bigger than, if you compute this on your calculator, you'll get exactly -1. So now to find this probability of z-score bigger than, so remember, if you have the normal curve, let's say like this, and then -1 is here, so you want the area to the right of -1. That is the probability z bigger than -1. But you know, in order to use the z-score table, we need probability of z less than -1. So we will change this because we know that the total area is 1. So this will be 1 minus the area below -1, or to the left of -1. So this would be the answer. And now we use the z-score table or the z-table. Probability z less than -1. So we go to the table. Where is -1? -1 is here. -1.0, of course. So we go and see what's the number that we have. And so here, it's 0.1587. So now we go back and subtract it from 1. So 1 minus 0.1587. And this will give you 0.8413. So this will be your answer. And if you want it as a percentage, you know, it will be 84.13%. This is the area to the right of -1, the z-score -1. So for the second one, for B, let's use a different color. So we want to do probability that x is less than 10.4. It's the same exact way. So you write, instead of x, you change to the z-score. So you put x minus mu over sigma is less than 10.4 minus mu is 17.4 over sigma, which is 2.8. So you compute this. This will be equal to, so you can say this equal. So this is the probability that this is the z-score less than. If you use your calculator, you'll get exactly -2.5. Let's write it 2.50, so 2 digits, so that you can use the table immediately. Now, because it's less than, it means that we want the area to the left of -2.5. So let's say -2.5 is here. So this is the area that we want. So we expect it to be small. So let's go to the Z table and see -2.5. So -2.5 is here, and 0, 0. So this will give us the number here. And this number, because of the previous problem, the blue thing is on top of it. So I'm going to erase the stuff here, yeah. So you can see that the number is 0.0062. And so you go back and you say that this probability is 0.0062. And this is the same as, if you want it as a percentage, this is 0%, 0.62. So it's less than 1%. Okay, and the last one, we want the probability that our random variable is between two values. So again, we change to the z-score. So this will be probability 16.7 minus the mean 17.4 over the standard deviation 2.8 is less than, now z instead of x, so you put x minus mu over sigma, which is z, and here you put 20.24 minus the mean 17.4 over 2.8, the standard deviation. So equal, which is the probability, if you compute, you'll get negative 0.25 less than z, less than, if you compute the second one, you will get 1.01. Okay, remember for the z-score, you do it to 2 digits when you are approximating on your calculator. So this, if you remember, if you watch the previous parts, this is the probability of z less than the bigger number, which is 1.01, minus the probability that z is less than the smaller number, in this case negative 0.25. And so let's go to the z table to get these two. We can use the z table immediately. So 1.01, so here is 1.0 and here is 1. So if we go, we'll find that it is this number here, which is 0.8438. So I will go back and put that this is 0.8438 minus, and now we want z less than negative 0.25. So negative 0.25, this is negative 0.2, and here is the 5. And so if you go like this and go from here, you will get this number, which is 0.4013. So you just go back and subtract 0.4013, and this will give you on your calculator 0.4425, which is, this as a percentage, 44.25%. Again, if you want just the graph, to see it on the graph, it will be like this. So this is the normal distribution, and you want between negative 0.25, so that's very close to 0. It's like here. This is negative 0.25 up to 1.01, which is here, 1.01. So this is the area that you want to measure, and we found that it's almost 44%. So, and it looks like it's correct from just what I graphed here. From the total area, this is like 44%. Okay, and this is how you solve such questions. Just remember, I'll repeat it one more time. Sometimes you are given the variance in the question, so you don't use this number. You need to do the standard deviation to be able to use the z-score, because the formula for the z-score uses the standard deviation in the denominator. Just remember this. And everything else is simple. Just change from x to z and then solve using the z table. And I will stop here.